Hi, I'm Brad, and I talk about display technologies for XR way too much. So let's make another video about display technologies for XR. Before I go into talking about all this, if you want to support this channel and everything I do, please join my Patreon, bradsmells.com/Patreon. This past week, there was a lot of big hopes and hype for Google stepping back in the XR industry. Well, this has kind of been trickling back in for a while. Google is not a stranger to the XR industry, but their really investments in it have been minor at best. They've done some really interesting things with like Google Daydream and stuff requiring a smartphone, but dedicated XR hardware has been something they dabbled into but never really focused and like really seemed like they were going to hop in heavily. It wasn't until this year that you just started seeing them acquiring some big talents from other companies like Meta, for example, to actually build like ecosystems and hardware and specialized R&D facilities to actually take advantage of this XR boom that we are right at the cusp at. That hype basically continued the past week when they bought a company known as Raxium, a full acquisition. No idea how much they paid, but it was probably a lot of money. Now, there isn't really too much to say about this acquisition, except there's a lot of companies that are buying micro LED companies that are interested in this space. In fact, I have a whole chart I'm going to probably put up here fancily, editing magic, to show you how many companies are being acquired by these mega behemoths corporations. It wasn't really the fact that I wanted to talk about this acquisition, I really wanted to talk about micro LED technology for XR in general. Because I actually get a lot of confusion because I talk about a technology a lot on this channel called micro OLED. And while there is a lot of similarities between them, their maturity and levels of what they can achieve are very different. So I figured I would take this opportunity as Google acquires this micro LED company to really give an explanation of what this technology will do, why is it better or less useful than other display technologies, and what kind of products you'll see it in first as it trickles and matures over time. Some of you may be watching this video and not even understanding that micro LED is different than micro OLED. That is a common thing in my comment section as well, so that's why I'm making this video. Now, before I go on in explaining kind of the basics of each display technology that exists for XR right now, I think it's important to get an idea of what these companies are wanting to achieve when it comes to releasing a product. Now, currently, most products on the market right now that are successful are full-on VR headsets. That is very easy to do because you are not expected to really recreate a glasses form factor. Now, the past 6 years, you might have noticed that AR glasses don't really exist. I mean, yeah, there's a few products out there, but primarily for consumers, you just don't see people walking around with AR glasses or really talking about them. And it's pretty obvious why. They are still very bulky, awkward, there's not much processing built in, so you have to usually plug them into a phone via wire, and really the capabilities of these devices just don't feel useful. Yet despite that, you see these large companies, when they talk about the XR industry, usually they're talking about how they see more value out of AR than VR. But when you see that, you must question to yourself, well then why are these companies working on VR headsets instead of working on making a glasses that can do everything on, clear, transparent glasses? Well, it's a very simple answer to a very complicated question. It's basically that technology is not there yet. Yeah. There's a lot of different technologies that need to mature and get smaller before we have this sort of dream of a all on-board processing super thin glasses that can fit every eye type prescription with displays of high FOVs over your entire peripheral vision. There's a lot of things that need to get better. So the industry as a whole has realized, okay, well maybe we need to learn how to get there by first working on VR. That's why even companies like Apple, for example, who are so focused on actually getting to that AR point, they are clearly working on more of a VR headset. But all these companies are working on VR to get there, and that's why we're seeing a transition from VR headsets to what is more called mixed reality headsets, or MR headsets. The idea is, since we cannot really pack everything into a thin glasses form factor with transparent optics with huge FOVs, we are going to transmute VR to AR using cameras and screens. But to ensure that we can actually have a transition period, we have to make these devices even more friendly to consumers than really what VR headsets have been the past 6 years. So you're going to see a lot of new technologies that really haven't existed for any product for a while, really just start to come together and be really amazing and really just entice people to see, okay, yeah, I can see how this can transition one day to something I would use every single day. And that's the promise of the metaverse, of course. A long spiel, but basically one day we will get AR glasses, but I wouldn't expect like true AR glasses for really like 10 years maybe. That being said, we are going to see a lot of different product lines from these companies, I would imagine, that are more closer to mixed reality headsets, but they'll also be releasing something called smart glasses. You're kind of already seeing some smart glasses released by Facebook and Snap, for example. Now, the Facebook Ray-Ban smart glasses aren't too smart. I mean, yeah, they have onboard audio and they have cameras, and you can kind of control them with your voice, but they're missing displays, and that's really a big part of what a lot of people think XR is when you have that visual component. Snap, on the other hand, is going on full out with the actual having glasses that have built-in displays, and even though these glasses are more still kind of a fashion accessory and a thing to aid a mobile smartphone, that's really what smart glasses are going to be for a while. Now, for these smart glasses, which will be a whole product similar to smart watches, what they will be pairing with a lot of devices, you want to have tiny display engines is what they're called. So this is where we get to talk about all the display technologies. So keep in mind that there's MR headsets and there will be smart glasses probably within the next 5-year products from these large companies. So with the first step to AR, VR headsets have been using technologies that smartphones have basically been using, and they've been taking those smartphone technologies and putting them into different husks with onboard processing more recently, to give a more consumer-friendly experience. Of course, we're going to be focusing on displays today, and displays in these headsets are usually LCD or OLED. LCD or liquid crystal displays are basically a bunch of tricks using a backplane with some polarizers and color coding on top of that to generate a display or an image. Humans have become very good at making LCD displays. In fact, that's why LCD displays have kind of taken over OLED when it comes to VR headsets. A lot of LCD display makers were realizing, okay, well, the industry is kind of moving away from LCD and pushing toward OLED. So maybe there's a last-ditch effort where we can do something special for this booming XR industry and start making special displays, which are called fast LCDs, to aid, well, this industry. Basically, the most important component that you can compare LCD to OLED is the use of a backlight. LCDs have a giant backlight that is always lit to produce and kind of control how much light is being directed out of the display. A LCD display is basically as bright as its backlight is for the most part. And you want bright displays for XR technologies, generally because when you use a display for XR, you're placing a lens in front of it. And that lens may have a very different amount of efficiency based on what type it is. That goes even more so when you're talking about AR glasses, by the way. AR glasses usually use something called waveguides, which remove a ton of percentage of light, even more than a lot of these near-eye displays. I've talked a lot about pancake lenses. Yeah, those things remove a lot of light because they bounce things around and have a polarizer, but that's still not nearly as amount of light that AR glasses, for example, the optics in those take away. So that's a whole other thing that they got to figure out. Now, more recently, I've been talking about how Cambria, Facebook's next VR MR headset, which again is more toward the MR than the VR, is going to be using something called MiniLED. Now, this is where a lot of analysts that even I respect and know are very smart people, they get the confusion that MiniLED is sort of a transition point to MicroLED. But I wouldn't really say it that way at all, in my opinion. MiniLED and LCD are basically very same when it comes to the technologies and the backing of how they work. They all have polarizers. It's all the same liquid crystal technologies creating the colors and everything. The big difference between LCD and MiniLED is LCDs have one backlight that's always on, but MiniLEDs basically have a very fancy backlight that instead of having one giant light on the entire display, they have something called local dimming where a bunch of much smaller LEDs can light up individually to make it seem like that each pixel on the display is trying to light up individually as well. There's something called perfect blacks that OLED has. It's basically with OLED, every single pixel on an OLED display is lighting up by itself with organic material. So if you have an entire black screen and only have a white cursor, that white cursor is the only thing on the display that's truly on. But for mini LED, if you have a cursor on a black screen, you're not going to have a fully true black, but you're going to have much better blacks than LCD because depending on how many zones of mini LEDs you have, that little area around the cursor is still going to be a little bit sort of blurry and lit up, but the entirety of the screen is going to be a lot more black than LCD. Now, humans have been using OLED displays for the past, I would say, decade, primarily very well. It is a transition point in a completely new technology compared to LCD. Again, it's self-emitting, so every pixel is lighting up by itself, and it's using organic materials. But these organic materials do degrade over time, especially usually the blue color degrades first, and that's why you get burn-in, because usually when you're using organic materials, each color, red, green, and blue, are usually using a different material. The OLED industry has been working hard to fix this problem, and there's actually been some strides recently, even though it's not hit the consumer market yet. But just like LCD, humans have been getting very good at making OLED displays. It is becoming more of a mature technology in general, but there's still issues with OLEDs that kind of make other technologies more attractive in the long term. Brightness is an issue for displays in general, especially as we want something called HDR displays, which are high dynamic range, allow much truer colors similar to what we get in the real life. And a lot of that HDR level is based on how bright the display can get. And the brighter you run a display, especially an OLED display, most of the time it's kind of like how fast these materials will degrade. There are ways to get past this, and I've talked about that in many previous videos. But yeah, that brightness is a problem, especially for XR devices who need high brightness as they pass through an optic. But one thing OLEDs have over LCDs, despite that brightness, is they have a faster response time mostly, which is pretty important for motion sickness. If you are responding and moving your head fast, and the display is moving as fast as your head better than LCDs, then people are generally going to have a better time. But there's a lot of other issues with the standard OLED, then, well, we'll get to that later. LCD, Mini LED, and OLED, standard OLED, all three of these are built on a glass backplane. Basically what display fabs do is they have a giant substrate made of glass, and they'll call them Gen 8.5, Gen 7, blah, blah, blah. Basically those generations are basically how big the entire substrate is. And these display fabs are generally patterning the entire substrate. So if you have like a, for example, 2200 millimeter substrate, that entire piece of glass is being patterned by OLED or LCD, depending on whatever fab is doing what. And then they'll cut those entire glass pieces and make smaller displays out of the giant substrate. But the issue with glass substrates is, for XR, you want really high PPI devices because of the screen door effect for the most part. The screen door effect, if you don't know by now, is basically the gaps between pixels, these black lines as you see it, which is usually not a problem for smartphones or TVs because the distance they are away from your face. But usually with XR, these displays are close to your face and these optics you have in front of them are usually magnifying the image, so you'll notice the screen door effect. The screen door effect for standard OLED displays were kind of bad and would cause something called ghosting, especially. If OLED displays were able to pack in the basically the spaces between the pixels better, that ghosting wouldn't be as severe as a problem. So those three technologies though, they are cheaper because they are built on a glass substrate. They are using displays that are used for other devices so they can transition into VR headsets to make the overall cost cheaper. So now that's where we need to start transitioning our thoughts into micro displays. Now micro displays takes out that entire idea of using a glass substrate and uses a silicon substrate. Micro LED, LCD, and OLED can all be built on micro displays. In fact, another name for all these different micro displays, for example, LCOS, which is LCOS, is liquid crystalline silicon. OLED micro displays, OLED on silicon, and then there's micro LED micro displays, which is micro LED on silicon. Because we as a human species have become so good at making things small and good with actual silicon backplanes, which we use for making chips, companies have been trying to figure out how to leverage that knowledge and that know-how and that experience to actually pattern displays into tiny nanometer form factors. All the problems that these other technologies have on glass substrates with the PPI limit and all these other things are removed when you build on a silicon backplane. That's why when I talk about displays that can be only 2 inches but yet 4K by 4K across, That is very high PPI. In fact, that's not even that high to what some other displays can reach if you have really some high goals, depending on what you're trying to do with the display. Just like how glass substrates are, usually you get a giant, well, it's not actually that giant compared to glass substrates. Usually you would get like a 12 or 8-inch silicon wafer, you would design the backplane, and then you would pattern the OLED or micro LED on top of it. Basically, you're taking all these technologies and just relying on the actual silicon backplane, which adds costs, and especially in a chip shortage time where you're trying to have more sort of capability to pattern displays on silicon. It's just another thing that's gonna like kind of overwhelm the demand for products made from foundries like TSMC, which is why companies like Apple are working with companies like TSMC when they're developing micro LED or micro OLED technology. You'll see that reported everywhere, and it makes sense. TSMC probably want to get in the display business as best as they can because they see some even more capabilities to step out of their horizon and expand their market. But yeah, earlier I said that mini LED to micro LED is not a transition. There's a lot of differences between them. I would count actually micro LED similar to OLED. Basically, micro LED is self-emitting pixels, but they're using inorganic materials, which allows them to get way much brighter than OLEDs. We're talking about in the million of nits for some of these displays and these pixels, which is crazy because the idea that you can have a million nit display with a high PPI and multicolor, that is a dream come true for AR technology that want to have these just insanely high resolution and high FOV displays in clear glasses form factors. But it's not that perfect yet. The reason why companies are trying to push micro OLED first for VR and MR displays is really due to the fact that there's a lot more maturity with OLED technology and how to make OLED displays than there are with micro LED. You might have seen some micro LED TVs, for example. While the display process is very different to making a large TV to a micro display with micro LEDs on it, these large TVs get into the hundreds of thousands of dollars. And even those micro LEDs are not really the same micro LEDs that you would put on a silicon wafer, because you usually have to scale down those micro LEDs to be even smaller to fit onto these tiny microscopic displays. And then you have to add the problem of color conversion. Most micro LED micro displays actually are not RGB yet. Most of them still are trying to get there, and there's a lot of different ways you can do it. One idea is using quantum dot technology to convert the colors into multiple things, but quantum dots also have issues when you scale them down to microscopic sizes. The most common way that people have been trying to make RGB micro display or micro LED displays is having multiple light engines like red, green, and blue, because you can make them monochrome, you can make them one color, no problem, and then you would use waveguides to combine those three colors into one RGB image. But that also adds some efficiency problems, and colors might not be as bright as the others when you do that. There's also the problem that these custom micro LEDs also scale with the resolution. When you're talking about micro OLED, you're usually talking about high resolution, and while these are already kind of more expensive than standard glass backplane displays, micro LED takes that even further. You're not going to get a 4K by 4K micro LED micro display at a large form factor like anytime soon, especially if it's full color. But getting a monochrome, low resolution micro LED display that's super tiny, can fit in a glasses form factor and act as a data glasses, yeah, that's going to be very useful. So when you see these companies investing in micro LED, of course they are hoping that it will get mature enough so they can put them in every device they own. But for the most part, you're going to mostly see these products in what are called smart glasses or data glasses, things that overlay not really the immersive environment we see in VR and MR, but stuff like notifications and basic ideas of what you will see in the real world to kind of aid you as similar to what a smartwatch will do. And the promise of AR is interesting. I once heard that Skiva, another content creator, said that we've become sort of a one-hand species with smartphones. Whenever you talk to someone and they're trying to look something up, usually they're only being able to talk with one hand. But the idea of AR is we'll be able to kind of replace our smartphones with these high-tech glasses and become a two-hand species again. I've always liked that term. I think that's a really smart two-hand species. Yeah, I like that. So AR as a promise does have value. If it can replace our phones that we're constantly holding and have eventually a way to actually turn our actual glasses into theaters at any moment, yeah, that technology sounds amazing. But really, there's so many pieces that have to come together slowly for that to happen. MicroLED technology has a lot of promise, and I really do think that it will take over every other display technology when we get to that point. That's why there's so much hype in the industry, and you see all these companies investing in it. They have to buy the best companies that are really exploring this technology while it's new and doing some amazing things, and eventually it'll pay off for them. It's not like LCD or OLED where there's some major players that kind of know how to do everything. MicroLED is still new enough to where these small companies that are being acquired by these large companies have their own value. They're figuring out different ways to build these things, and they're usually better. So yeah, that's all the differences of display technologies and how they apply to XR. If you have any questions about the different display technologies, I know this was a very long video than I really expected to make, but they are all very applicable to the next coming wave of VR devices. Don't be afraid to ask questions in the comment section below. If there's anything I want you to get out of this, I want you to understand that MicroLED will be very useful for smart glasses right away, and MicroOLED will be useful for VR MR glasses right away. That's basically the two TLDW of this video. Anyway, I hope you have a great week and see you next video.